In the next few videos, what I'd like to do is to show that the Euclidean algorithm for finding the greatest common divisor of two positive numbers, two positive integers, represented by this algorithm is correct. So, first of all, in order to show it's correct, I'm going to need to use some laws of greatest common divisors, and I'm not proving these. You would learn to prove these in an algebra course. But if x is less than y, the greatest common divisor of x and y is the same as the greatest common divisor of x, y minus x. If x is greater than y, the greatest common divisor of x, y is the greatest common divisor of x minus y, y. And if x and y are equal, their greatest common divisor is themselves. So we'll use these laws in order to prove our algorithm correct. Let's take a glance at this algorithm. So we start off in a state where x hat, the input in x and the input in y, are both positive. And then the invariant is that the GCD of xy is the same as the GCD of the original x, the original content in y, and x is still positive but less than or equal to the original content, and y is positive but less than or equal to its original content. As long as x is not equal to y, what we're going to do is, well, it's going to depend. If x is less than y, y becomes y minus x. If y is less than x, x becomes x minus y. And we continue this until they are equal. We leave the loop and end up in a state where the greatest common divisor of our original content is the x and y that are equal to one another. So, just to make sure we have an understanding of this algorithm, I thought we could go through and look at the algorithm applied to a couple numbers. So I picked the numbers 45 and 150. So originally, y is larger than x, greater than x. And so x stays 45, but y becomes 150 minus 45, or if I did my arithmetic correct, 105. 105 is larger than 45, so x stays 45, and now y is updated to now being 105 minus 45, which is 60. They're not equal. Y is still larger, x stays the same, and now y is 60 minus 45, which is 15. They're still not equal, but now x is larger, so y stays 15 and x becomes 30. They're still not equal. One more time. Y stays the same, it's 15, and x is 30 minus 15, which is also 15. So now that they're equal, that tells me that the GCD of 45, 150 is 15, and I think it worked. So in the next video, what I want to do is map out the different predicates we will need to show to prove that this code segment is correct.